All right, so here is a continuation of section number 3. And this section, we are currently on pages 31. So pages 31, open to pages 31, and we'll be talking about proportions. So far we've discussed ratios, we've discussed scientific notations, all right, and per capita, and we're going to be dealing with proportions at this point, okay? Nice. So this is one of, everything is important, but proportional thinking is a cornerstone of quantitative reasoning, and we're going to look at applications of proportions in our next section. All right. So basically, two fractions are said to be proportional when they are equal. All right, so let me give you a quick recap. We may have come across proportions before. So let me give you some basic examples of proportions. So I'm going to switch my screen and share a wide screen with you. Okay, sweet. So if I have 2 over 3 is equal to x over 4. And you're asked to find x. How do you do that? So what you have to do here is what you call cross multiplication. So you cross multiplication, and this means that 2 will multiply 4 and 3 will multiply x. So I have 8 is equal to 3x. All right, now we want x, so we divide both sides of the equation by that. So we have x to be equal to 8 out of 3. All right, now these two fractions are proportional, and we have to find the other. So basically, this is the whole idea. This is what we're going to be doing for this section. We're going to set two fractions proportional, we cross product, and we find the missing variable, basically, okay? So I'll just take you back to elementary school, maybe. All right, so let's go back and look at how we can do it proportions. So our goal here will be to, these are objectives: construct proportion equations based on a story problem, and solve proportional equations, and construct expected value proportion equations based on a story problem. And we'll look at how we can interpret value proportion equations based on a story problem. Okay, sweet. Now, so here we are going to look at two different ways that we can do this. So this problem has been solved for you in your book, and I'll just give you an introduction. There are two ways that you can get this right. So the first way is that you can do same unit across. So we're talking about inches and inches, and we're talking about miles against miles. So this is the first method. And I won't spend much time on this because I want to be as practical as possible. So I'll go ahead and use some examples to explain this better. Okay, so there are two ways. Either you set same unit across, all right? So this way, same unit across. And then the other way is that you set same unit vertically, all right? And either way, you get the same result. Is that okay? Now, let's get into some examples. So I'm going to post this out for you. So this is similar to what we just looked at. So here, we're going to set same unit, all right, horizontally, and same unit horizontally, and you get the same result. You can decide to use a different setup and you still get the same answer. But the next slide is where I start introducing you to how you can do this. I know the questions that students usually ask is, what goes to the bottom? Okay, what goes to the top and what goes to the bottom, right? I'm going to teach you a very simple and easy way to do this so that you wouldn't have to bother about what goes to the top and what goes to the bottom. So here, it says a couple ordered 70 ounces of pate for their engagement party of 45 people. the pate was such a hit that the couple has decided to serve it again at their wedding reception. How many ounces of pate should they order for 315 people? So here, what are we talking about? We're talking about ounces, okay? And we're talking about people, okay? So I grouped them. I try to extract, get the context out. Now, so the couple ordered 70 ounces. So I'll put 70 under ounces, and then I'll put 45 here. So they ordered 70 ounces for 45 people. All right. Now we want to know how many ounces of pate should they order for 315. So here we don't know the ounces that they need to order for 315. So we're going to say this is X. And we are going to put 315 right here. Okay. Now, when you do this, now you establish a proportion. How do you do that? Now, divide, just introduce a division sign and introduce an equal sign. You have established a proportion right there. Okay. Now, what do you do to solve for your X? You have to cross product, right? So you're going to have the cross product, and you're going to have 70 times 315 and then X times 45. So you're going to have 45X is equal to 70 times 315. Now you want to find your X, so you divide both sides by 45. You divide that by 45. And your answer will come out as 490. Okay, so that is how you go about this. Let me clear that real quick. So that is how you do that. And your X will come out as 490. And what's wrong with my pen again? So you have 490 as your result. Okay, let's take some more examples of this. So a house assessed at 73,000 has an annual property tax of 1,600. Okay, how much property tax would the owner of a house in the same neighborhood expect to pay if his house was assessed at 87,500? So what are we talking about? We are talking about the cost of a house and how much tax you need to pay. So I'll put, let me come down here, I'll put costs, okay, and I'll put tax. These are the two main things that I can extract out of the word problem. All right, so a house assessed at 73,000. So 73,000. Okay, I don't know what is happening. And the tax is 1,600. Is that okay? Now, the question here is that how much property tax would the owner of a house in the same neighborhood? So we don't know the tax, so we say that is X. Okay, and the house assessed at 87,500. So this is your setup. Now, establish a proportion by introduce a division, and equal sign. Okay. Now, cross product. And you have 73,000 X being equal to 1,600, okay, times 87,500. Okay, now you want X, so you divide both sides by 73,000, and you divide that by 73,000. Okay, now find your X. Okay, and your X will come out as X is equal to 1,917.81. Okay, good. So this is how you, so first of all, you just need to extract, know what you're talking about, put them side by side, and put the amounts that have been mentioned against the extracted information. Is that okay? And that makes it so simple. You don't have to worry about what goes to the bottom, what goes to the top, or what goes to the top. Gucci? All right, nice. Let's look at another one. Now, if 1 acre of land has 30,000 individual plants of corn, how many plants would grow on a 17-acre farm? So what are we talking about? We're talking about acre of land. So I'll put acres right here. And we're talking about plants, okay? So I'll underline them right there. Now, it says 1 acre of land. So 1 acre of land is for 30,000, goes for 30,000 individual plants. Okay. Now, how many plants would grow on a 17-acre? I don't know how many plants are there, so I will say that is X. Okay. And then I have 17 right here. Now I want to establish a proportion. Okay. Nice. So I have my X being equal to 17 times, okay, 17 times 30,000. And that will come out as 510,000 plants. Is that okay? Good. So basically, this is how you do it. Extract the information and put the information side by side. Establish a proportion, cross product, and find your X. All right, let's look at this. Larry is creating a mural from a photograph he took while on vacation. He has decided that every 0.5 inch of the photo will equal 4 inches. Okay. Of his mural. If the photograph is cropped to be 77 inches wide, how wide will the mural be? Okay. So we're talking about mural and what? Photograph. So Larry is creating a mural from a photograph he took whilst on vacation. So I'll put the mural here and I'll put the photograph. Right there, okay? So he has decided that 1.5 of the photo will be equal to 4 inches of the mural, right? So 0.5 of the photo will be equal to what? 4 inches of the mural. Now, if the photograph is cropped 7 inches wide, so the photograph is 7 inches wide, how wide would the mural be? We don't know how wide the mural will be, so that will be X, okay? Right from here, I introduce that, I cross that. I have fractions. I introduce my equal sign and I'll cross product. Is that okay? And my answer will come out. It's pretty neat as 56. Okay, so I just had to do 0.5x being equal to 7 times 4 is what? 28. And then I divide both sides by 0.5. Okay, I divide that by 0.5. Okay. And I have my X. I don't know, this is not working. Okay, let me write it right here. I think I came too low. Okay, so that's basically what happens. And then 0.5 is 1 out of 2, right? And that times 28 gives you 56. Okay, sweet. So that is how this works. Right? Now, here, Amy is taking 15 credit at IB Tech this semester and paid 1,997.25 from tuition. She is considering taking 11 credits in the summer. How much will her tuition be? All right. So we're talking about credit and cost of tuition, right? So I would put credit and cost of tuition right there. So Amy is taking 15 credit at Ivy Tech. So 15 and Amy pays 199.725 for tuition. She's considering taking 11 credits. So I'll put 11 right under credit. And we want to know how much Amy is going to pay for the summer. Okay. So once I have this, I just introduce division sign and I'll introduce an equal sign. Okay. Right away, I have 15x and then it's equal to 11 times 1997.25. I divide both sides by 15 and we have Amy's cost of tuition as 1464.65. Okay, this is pretty simple. If you are able to extract the information and put them side by side, it makes it very easy for you to simplify. Don't pay attention too much to the wording. Sometimes I know students get lost in the wording such that they don't even know how to go about it, but just extract the relevant information out of the word problem and just go ahead and do it. All right, cool. All right, so here a 35-pound child received 525 milligrams of antibiotics. If the dose is to remain proportional to the body weight, how many milligrams of antibiotics should be prescribed to a child who weighs 68 pounds? Okay. Are you trying to put them side by side? Yeah, think about it. Give it a thought for a second. Okay. So we're talking about weight and so we're talking about weight of a child and how many milligrams of antibiotics that should be dispensed, right? Now, so we have weight of the baby or of the child and the volume of antibiotics that should be dispensed. Is that okay? So I'll do that. And then I have 35 and that child should be given 525. Is that okay? Now we want if the baby or the child weighs 68 pounds, what volume of antibiotics should be dispensed? All right, I have my proportion. Now I introduce a division sign, and then I introduce my equal sign. Okay. From here, I'll cross product and find my x. And that will come up pretty clean. Okay. So a baby or a child who is 68 pounds should be given 10-20 milligrams of antibiotics. Is that okay? Good. So basically, this is how you deal with proportions, okay? So it's pretty simple. If you have a word problem, don't get lost in the word problem, all right? Just distill the right information out of the problem, put the numbers side by side, introduce your division sign, cross product, and solve for your x. Is that okay? So right now we're going to be talking about population density. And we actually skipped that page. So that is on page 30. All right. So population density. And be careful you don't confuse population density with per capita, right? So population density refers to the amount of people per square area of land. So people per square area. That means that we're going to divide the population by the square area. Is that okay? So for the United States, the population is 30309 million. Is that okay? So I'm going to do that of the United States right here. So we're going to do 309, and this is a million. And then we divide by the square area of land, which is 3717 811. Oh my goodness. I don't know why my pen keeps striking out. 3717811. Okay. And that will come out as that. Okay. So that is how you do for the rest. So make sure for population density, you divide the population by the area. The difference between population density and per capita, for per capita, the population goes to the bottom, right? You divide whatever is being discussed by the population. But for population density, you flip it. Is that okay? Good. So don't get confused, right? So all you need to know the difference. Now, using the data above, if the proportion of people to square miles were the same in Japan as in the United States, okay, how many people would be expected to live in Japan? So this is how you do it. And I'm going to give you a very simple way to look at it. So we have the United States and Japan. Okay, so we're talking about the US and Japan. So if the proportion of people to square miles were the same in Japan as in the United States, how many people would be expected to live in Japan? So we are going to assume that we do not know the population of Japan. Is that okay? That's basically what we're going to do. So let me use a whiteboard. I'll give you the answer, but let me show you that on a whiteboard. And let's discuss that because we're going to do more of these under the application of proportions. Okay. And so let me do that. So we are talking about the United States. So we are going to extract the United States. So if you look at the table, we have country. Okay. And we're talking about, we also have the square area and we have the population right there. I'm referring to the same table, right? Now, so we're talking about the United States. So the US is right there. And we are talking about Japan. Is that okay? So we are going to repeat almost the same information. But the question says that if how many people will be expected to live in Japan? So we assume that we do not know the population of Japan. So under the population of Japan, we're going to put X and repeat every other information that goes for Japan and the United States. So the US has a square area of 3717811, and the population is 309, and this is a million, don't forget that. And that of Japan, the square area for Japan is 145,883. Okay, so look at how we establish the proportion. I'm just going to introduce division, and equal sign. Is that right? And then I'll cross product. And that will give me the result. So I'll multiply this and that and this and that, and finally divide my result by 3717811. And my result is going to come out. Okay. So let's go back and I'll show you the answer. And that is how this answer came about. Okay, so that is it. So this gives you that as your result. Okay, we're going to do more of these applications. We move to the next section 14. But this is how you do it. So extract the two countries, the information for the two countries. What are we expected to find? Okay, we represent that by X, all right? Cross product and find the answer. All right, nice. So how does the answer to the previous compare to the actual population. All right, so you find a difference between the two, and that gives you the result. Which country listed in the above has the largest number? So you just look at the two, and you look at the countries and select the right one. Now, which country is it on the table has the smallest? Iceland, right? And what does it mean for two countries to be proportional in terms of their population and area of land? Okay, good. So basically, that is all I want us to discuss under this section. We will find time to deal with these practice problems, okay? So that's it under proportions, okay? And thank you for your time. And I wish you good luck. Thank you very much. Bye-bye.